let me write the example. It is basically a differential equation which is describing a continuous time system, of course. So dyt dt plus 3yt, which is equals to x of t. Now, as you can understand that this is basically a first order. Coefficients are also constant. So first order constant coefficient, order constant coefficient, and causal differential equation, this equation. And here also you just assume that xt is given. In some form it is given. You just assume it. Now what is desired? It is desired to compute the output yt. But how? With the help of a computer. You know, in computer or any kind of like in simulation environment, if you take the help of that, so there or any kind of software, basically the continuous time or continuous variables are not allowed. So before doing any processing or computation, we have to discretize it. We have to convert to change the domain from the continuous to the discrete. Now here also you have to do the same thing, because we have to simulate, because for some purpose, suppose for some purpose it is required. So that means this computation we will do with the help of a computer. Now, so actually what computer does, or the way the software programs are written, what it does actually, that we'll try to get a little bit flavor of that. But it is actually a continuous time domain differential equation, first order constant coefficient differential equation, and of course causal, it is mentioned. So where some form, if you fit xt in some form, you will get yt, the output. So, and we are basically interested to find out that what is the form of the output yt. Now, in doing so, we have to basically invoke the concept of, the differentiation. We all know the concept in calculus. We all know. So the differentiation. So basically, what is dyt dt? The first term. The dyt dt, it's basically the derivative of yt with respect to the t. And you are differentiating yt with respect to t. Now, you know how to approximate this thing in calculus. The same concept you have to apply. So in calculus, what do you do? Suppose, for example, so this is the equation. So I'm writing here. So suppose I can write it like, this is not one thing. I've already mentioned this is in continuous time domain. So for the computational purpose or for the simulation purpose, I have to discretize it. This is a point to remember. So discretize means the operation that you have to apply or you have to employ is the operation of sampling. You know that. So sampling means some sampling time interval or the sampling period. This kind of concept we have to apply here. So that means dyt dt, I can write it like this: y of n, say ts is the sampling period, say for example n ts, minus y of n minus 1 into ts. Okay, this thing divided by ts. This is nothing but your dyt dt. So basically when we are converting this to the discrete time domain, so that means when we are discretizing it, it is basically the difference between the numerator, the difference between two consecutive or successive samples, that is the nth minus the n minus 1th. So divided by the ts. So ts is basically the that intermediate step in the time domain, or the time step people call, or simply the time sampling period. So this is ts. So this is basically, this will give you this thing in the continuous time. You know that from the calculus. So this part is important. If you can replace this by this, then the rest of the things are just mathematics. Okay. So similarly, suppose for example, say yt. How to write the yt? So yt again. Sorry, not yt. I'm sorry, because I'm converting to the discrete time. So let's write it like yn. How to write yn? yn is basically is equivalent to here, is basically equivalent to, you can say it is y of n ts, suppose. Again the same thing, y of n ts for any value of n. Again xn, how to write xn? Xn can be written like, again it is equivalent to your x of nts. Okay, these are the things. So that means we have to basically convert that equation when it's written over there. So we have to convert it to the, obviously retaining its property, means the causality, okay, the first order nature, coefficients should be constant, all these properties and should be retained. So we will basically convert the differential equation into a equivalent difference equation when we replace these factors by these terms. Okay, so finally what we can write here, so if you just replace these terms by this, then what we can write it, like say for example I can write it কি হবে, ফার্স্টে যদি তুমি এটাকে রিপ্লেস করো dyt dt, এটাকে যদি এটা দিয়ে রিপ্লেস করো, ts নিচে থাকলো, আর এখানে আছে y of t. And okay, you can do another thing. You don't need to write ts again and again, as you know, because it's a uniform sampling. So in uniform sampling, we generally do not write like here, or what I have written, that yt was replaced by nts. Then that nts, we don't use the ts again and again, because that is uniform, that is same for every sample. So we just write y of it. So you don't need to write y of ts, y of nts rather. So ts, just omit ts here also, you just omit ts, all from all the places you just omit ts. But please note, you cannot omit this ts. Okay, you cannot omit this ts, because that ts is important, because you have to basically divide that. So that is as I mentioned, that is the time step of the sampling period, that you cannot omit. So finally this can be written like your, এটাকে রিডিউস করলে কি হয় বলো তো, একটু ঝট করে কেউ বলো তো তাড়াতাড়ি, এটাকে রিপ্লেস করলে করে একটু রিডিউস করলে কি হয়, কি লিখতে পারি? y of n এখানে থাকবে একটা, এখানে থাকবে 3yn. সো yn যদি কমন নিই, আমার এখান থেকে যেটুকু আমার মনে হচ্ছে এটাও একটা টার্ম আসা উচিত, 1 প্লাস, আর ts দিয়ে মাল্টিপ্লাই করে দাও both the sides. So if you multiply here the ts into xn, একটা টার্ম আসবে এখানে, ts into xn, আর এদিকে এখানে ns yn আছে, এদিকে একটা yn আছে, but that yn is multiplied by 3. So again it should be আর ts দিয়ে মাল্টিপ্লাই করেছো, so again 3ts I think. দেখো তো আমি ঠিক করলাম কিনা, yn, আর এখানে হবে একটা নেগেটিভ সাইন, নেগেটিভ y of n minus 1. সো নেগেটিভ y of n minus 1 একটাই আছে, তো ts দিয়ে মাল্টিপ্লাই করেছো, আই থিংক শুধু এটা থাকা উচিত, n minus 1. এটা আসছে কি, দেখো এই স্টেপটা যদি ঠিক না হয় পরে গন্ডগোল হয়ে যাবে, একটু আমাকে ক্ল্যারিফাই করো। যে আমি যেটা করেছি সেটা ঠিক আছে কিনা সেটা একটু আমাকে এনশিওর করো।
Yes, sir.
ঠিক আছে তো একদম ওকে। তাহলে এইবার দেখো, তাহলে আমরা এবার কি করব, এইটা আমরা পেয়ে গেলে দেখো, দিস ইজ বেসিক্যালি আওয়ার ডিফারেন্স ইকুয়েশন. So from the differential equation, I have basically converted it to the difference equation. Now again, suppose এখানে আমরা ফার্স্ট অর্ডার নিয়েছি, ফার্স্ট অর্ডার ডিফারেন্সিয়াল ইকুয়েশন, কনস্ট্যান্ট কোএফিশিয়েন্ট. এটা যদি সেকেন্ড অর্ডার হতো, সেকেন্ড অর্ডার হলে কি হতো কেউ বলতে পারবে? কিভাবে রিপ্লেস করতাম? দেখি কে বলতে পারবে এই কনটেক্সটে. ধরো আমি প্রবলেমটা একটা ওয়ান লেভেল অর 1 ডিগ্রি কমপ্লেক্সিটি বাড়িয়ে দিলাম, আমি সেকেন্ড অর্ডার দিলাম. সো দেন হাউ টু ডিসক্রিটাইজ or how to replace during simulation process or computational process? d2y dt2 আছে ধরো. So then how to write? কি হতো ক্যালকুলাস আমরা কি করি? এটাই কি করেছি, দুটো স্যাম্পলের মধ্যে ডিফারেন্স ডিভাইডেড বাই তাদের ডিস্টেন্স, হুইচ ইজ টিএস. তা যদি আর সেকেন্ড টাইম ডেরিভেটিভ ডিফারেন্সিয়েট করি তাহলে কি হবে? সেকেন্ড টাইম ডিফারেন্সিয়েট করলে কি হবে, কিভাবে লিখবো? যদি সেকেন্ড অর্ডার ডিফারেন্সিয়াল ইকুয়েশন হতো তাহলে d2y dt2 টাকে কিভাবে লিখতাম? হ্যাঁ,
y ডিসি টার্ম তারপর
বুঝতে পারছি না তুমি কি বলছো, তো কথাটা ঠিক ক্লিয়ার আসছে না. ডিসক্রিট টাইম ডোমেনে ডিফারেন্সিয়াল ইকুয়েশনের ইকুইভ্যালেন্ট ফর্মটা কি হতো? or how to write it?
Sir, n-2 ts হতো.
n-2 ts হতো, শিওর? মানে y n ts minus y of n-2 ts, তার মানে you are basically মানে omitting or skipping one samples in between, তাই তো? দুবার ডিফারেন্সিয়েশন মানে কি গো? ফিজিক্যাল ইন্টারপ্রিটেশনটা কি? ডাবল ডিফারেন্সিয়েশনের ফিজিক্যাল ইন্টারপ্রিটেশন কি? আরে ইন জেনারেল কোশ্চেন করছি,
ডেরিভেটিভ এর স্লোপ.
ডেরিভেটিভ এর স্লোপ, ডেরিভেটিভ এর স্লোপ. আচ্ছা, আর ফার্স্ট টাইম ডিফারেন্সিয়েশন মানে
জাস্ট স্লোপ.
স্লোপ. তাহলে সেই কনসেপ্টটা যদি আমি যদি তোমার কথাটাই যদি ধরি, তাহলে এক্ষেত্রে কি হওয়া উচিত? তাহলে ডিফারেন্সিয়েশনে তো ডেফিনেটলি কনসেপ্ট চেঞ্জ হয়ে যাবে না, যে প্রবলেমই তুমি করো না কেন, বা যে ডোমেনেই করো না কেন, তাই তো? এখানে তাহলে কি হওয়া উচিত? এটা তুমি স্লোপ পেয়েছো অলরেডি, দুটো স্যাম্পল আছে, মানে ব্যাপারটা বুঝতে পারছো পিকচার কিরকম? একটা n-1, একটা হচ্ছে nth, তবে দুটো স্যাম্পল আছে. এটা দুজনের মধ্যে ডিফারেন্স ডিভাইডেড বাই এই যে ডিস্টেন্সটা. এই ডিস্টেন্সটা কি? যে স্যাম্পলিং টাইম ইন্টারভাল, বা যেটাকে আমরা টিএস বলছি, বা টাইম স্টেপ. বা স্যাম্পলিং পিরিয়ড যাই বলো, এই তো ব্যাপার। সো এটা হচ্ছে nts, এটা হচ্ছে n-1 ts, and in between distance হচ্ছে ts, আর তার corresponding value, the value of the sample at this point, the value of this point difference divided by this, just সেটা তো ডিফারেন্সিয়েশন। এবারে যদি সেকেন্ড টাইম ডিফারেন্সিয়েশন থাকতো, মানে আরেকটা যদি d2 t2 থাকতো, তাহলে কি হতো, মানে কি হতো, তাহলে কি সেক্ষেত্রে কি আমরা এটাকে স্কিপ করে দিতাম, এই n-1টাকে স্কিপ করে n-2 নিতাম? ধরো এখানে n-2 আছে, এটা নিতাম।
স্যার তাহলে যদি y অফ মানে এই যে পুরো মানে এই পুরো যে y অফ nts, হ্যাঁ মানে ওটাকে যদি একটা ফাংশন ধরি, তাহলে এবার সেটার ফার্স্ট ডেরিভেটিভ হবে।
কি হবে মানে আমি কি লিখবো সেটা আমাকে বলো ফাইন। আমি তো কম্পিউটারে প্রোগ্রাম করে সিমুলেট করবো, তো সিমুলেশনে আমাকে কিছু সফটওয়্যার প্রোগ্রামটা লিখতে হবে, তো আমি সেটা লিখতে চাইছি, সেই ইকুইভ্যালেন্ট ডিফারেন্স ইকুয়েশনটা কি হবে, যে ফর্মটাকে লিখবো তারপরে তাকে সিম্পলিফাই করবো, ঠিক যেটা আমি এখানে করেছি। আচ্ছা ঠিক আছে, আমি এখানে আর সময় নষ্ট করছি না, তোমরা একটু বাড়িতে চিন্তা করো, ঠিক আছে? এটাকে আমি তোমাদের একটা ছোট্ট অ্যাসাইনমেন্ট হিসেবে দিলাম, তোমরা বাড়িতে চিন্তা করে নিজেরা করবে, পরে আমাকে জানাবে। আমি এখানে টাইম ওয়েস্ট করছি না, চিন্তা করো, ঠান্ডা মাথায় চিন্তা করো, ক্যালকুলাসের কনসেপ্ট লাগাবে, তাহলেই হবে।
So that will be yn minus 2 yn minus 1 minus yn minus 2 by ts square.
শিওর এক্সপ্লেন করতে পারবে যেটা বললে?
Yeah, let's assume dy by dt as z. Okay.
Okay.
So my d2y by dt square will be dz by dt.
Okay.
So dz by dt will be zn minus 1 by ts. And z was yn minus 1 by ts. So when I put in the value of z in the derivative equation, we'll get yn minus 2 yn minus 1 plus yn minus 2 by ts square.
Okay. ও যেটা বললো সবাই বুঝেছো? ও যেটা বললো বাকিটা সবাই বুঝেছো? আচ্ছা তুমি, তোমার নাম কি? Archana Kumar. So what Archana told, so whether you all have understood? Archana repeat karo.
Yeah. Let's assume dy by dt.
আচ্ছা Archana কি শেয়ার করলে সুবিধা হবে? তুমি কি করেছো? তুমি শেয়ার, can you share it?
I'm explaining, I think.
Okay, you just explain.
Okay, let's assume dy by dt as z, okay? So my d2y by dt square will be dz by dt, isn't it? So my dz by dt
if anybody has any question or any objection, you just stop her and ask.
Yeah. So my d2y by dt square will be dz by dt. Now dz by dt is zn minus 1 by ts. And I assume my z to be dy by dt. So when I put the value of dy by dt in place of z, I'll have yn minus 1 minus, within brackets, yn minus 1 minus yn minus 2 by ts square. So when I evaluate the expression, we'll have yn minus 2 yn minus 1 plus yn minus 2 by ts square. Hope it makes sense.
Got it?
Yes.
প্রত্যেকে কারোর কোনো ডাউট আছে? আর ঠিক আছে, আচ্ছা ও তো বললো ঠিক আছে আন্ডারস্ট্যান্ডিং হলো, এবার নিজেরা করবে, নিজেরা প্রত্যেকে করবে। ও তো বললো মোটামুটি আন্ডারস্ট্যান্ডিং হলো, তো এবারে নিজেরা প্রত্যেকে করবে খাতায় করে এক্স্যাক্টলি এই ইকুয়েশনটাই যেটা আছে তার সঙ্গে একটা এক্সট্রা টার্ম যেটা এখানে অ্যাড করে দেবে d2y dt2 করে জাস্ট একে এই সিমুলেশন পারপাস আমি যেভাবে এখানে করছি সেভাবে করবে করে আলটিমেটলি বলে আমি তোমাদের তবুও এটাকে অ্যাসাইনমেন্ট হিসেবে দিলাম, ঠিক আছে, জাস্ট এ স্মল অ্যাসাইনমেন্ট, ভেরি স্মল অ্যাসাইনমেন্ট, বেসিক্যালি কিছুই নয়। তো অ্যাসাইনমেন্টটা করবে দিয়ে রেডি রাখবে, আমি যে কোনো সময় দেখতে চাই, এনি টাইম এনি ডে, ঠিক আছে, জাস্ট রেডি রাখবে বলে দিলাম। আচ্ছা সো যাই হোক আমরা এটা কমপ্লিট করি আপাতত যেটা করতেই আছি। সো বেসিক্যালি ইট ইজ দিস ফর্ম after just multiplying both the sides by ts, I am getting this form. So this is my difference equation, again the constant coefficient causal difference equation, first order. Okay, now the point is here we have to compute now, as I mentioned, we have to find out y of n. What is y of n given any xn? Actually given any xt, what will be my yt? So for that I am doing this. So here suppose it is already mentioned it's a causal differential equation. Now please note here we have to first, what we have to do, we have to first find out the impulse response for this system. Impulse response, because if we know the impulse response of the system, we know how to find out yn given xn. We know that, we know the technique. So here what will be, sorry, my xn will be first I have to apply xn equals to del n, because to find out hn we have to first apply del n at the input. So xn, the first case xn will be del n, so just replace your xn by del n. So if you replace this, now just look at here, you know where del n or when del n actually exists. Del n exists for n equals to 0. Now for if you put n equals to 0 here at this side, if you put n equals to 0 here, it will be y of -1. If you put n equals to 0 here, it is y of 0. Okay, no problem. But the point is actually if you put here n equals to 0, then it will be y of -1. Now what is y of -1 for any system? What is y of -1? Y of -1 is basically nothing but the initial condition for that system, initial condition. And we know that it is already given that it's a causal differential equation, or that the differential equation describing a causal system. And that means this y of -1 should always equals to 0. It is always equals to 0. So that means the initial condition should be 0. So y of -1 is 0. Now, if y of -1 is 0, then obviously here I can write like h of n. H of n is nothing but your impulse response. Okay, so which is basically nothing but your y of n. So when you are applying del n at the input, so h of n is what? Let me write it also for your convenience. This is nothing but your y of n on application of del n. So which is nothing but what is coming? Okay, let me write the whole terms actually. So the first term should be your divided by 1 plus 3ts into y of n-1, and plus it should be your ts, this ts divided by 1 plus 3ts, and here you have del n. So this is the actual equation. Okay, I should write like this first. Then if I put, this is the systematic way I'm approaching in a very systematic way. So it should be, if you put 0, then obviously as I mentioned here, it would be in this case, this would be h -1, and this is del of n at n equals to 0 is 1. So it is basically ts by 1 plus 3ts. And as I mentioned, this is precisely equals to 0. So you can directly write h of 0 is actually nothing but your ts divided by 1 plus 3ts. Like this. So we got what is the impulse response for the system at n equals to 0, which is h of 0. Now to find out h of 1, what I will do? H of 1. Now again, look at here. It is my general expression. Basically, these are basically same, but I have written, rearranged the terms like that. So it is, if we put now n equals to 1. Now please note, when you are putting n equals to 0, obviously there is no existence of delta n. That means delta n is precisely equals to 0. So this term will vanish when n equals to 1 onwards. N equals to 1 onwards, this term will vanish. Now if you put n equals to 1 here, so this will be y of 0. Y of 0. Now, and which is nothing but your h of 0. Y of 0 is nothing but your h of 0. Now you already know what is the value of h of 0. So if you put that value here, and this is the constant, so it will be nothing but your it will be Ts divided by 1 plus 3Ts whole square, like this. Again, similarly, if you move on, it will be again h of 2. Same case, when you put n equals to 2, again there is no existence of this term. And if you put n equals to 2, so then it will be y of 1. Y of 1 is nothing but h of 1. So h of 1 is this, and again it is divided by this, so it will be your Ts divided by 1 plus 3 Ts whole cube. Just to note that here at the argument you have 0, and here the power is 1. In the argument you have 1, the power is 2. Argument you have 2, the power is 3. So basically, in general I can write, so my hk for any value of k, the general expression would be Ts divided by 1 plus 3Ts whole to the power, obviously k plus 1. Up to this, is it okay? So this is computed, kind of, it is computed in a recursive fashion. Please note it carefully. It is computed in a recursive fashion. So it's like recursive. So we got one value, we plug in that value, again we got from that, we got something, again we plug in that in the next step. It's like that. So it's basically recursive. So in hardware, you can also implement the same thing by using feedback. And in software, it's less a recursive program, like you're finding out the factorial kind of thing. Okay, so here the impulse response of the discretized version of this differential equation, okay, is nothing but, how to write that? Is nothing but your, suppose, let me write in general, Hn is equals to, I have to write in a segment, in the form of a signal, okay, in the form of a signal, because after all, the impulse response, you know, it is after all a signal. You know that, I already discussed it. So Hn, so these are the in general individual terms, probably you can remember, but this is not a signal. This is just the individual terms. So in general, I have to write it in the form of a signal. So how to write it? So it is basically Ts divided by 1 plus 3Ts whole to the power. Obviously, here I have to write in terms of n, of course. So it will be n plus 1 into, please note, into un. Unless and until you multiply with the un, it will not give you a form of a signal. So un Ts divided by 1 plus 3Ts whole to the power n plus 1 into un. That is the impulse response of that discretized version, which is written in a green color, of that differential equation. This is the thing. This is a signal after all. Hn, this signal. Now, if I know this signal, or the pattern or the form of this, then given any input, doesn't matter. I will simply do the convolution and we'll find out the output y of n means actually y of t. Okay, so that is possible. So that means it should become clear that this discrete time system is indeed time invariant. Where from I'm getting this information that this system is time invariant? Because here also when we are doing the recursion, okay, when we are actually computing the things by using recursion, And you just see basically the responses. If you suppose shift your delta function, this function, suppose instead of n, if you make the delta function occur at delta n, what would happen? Like what I'm trying to say, like suppose instead of this, if my delta function appear for n equals to capital N, suppose at times in instant n, capital N, if it occurs. And obviously under that condition, your y of capital N minus 1 would be 0, because after all it's the causal. So before application of that impulse, there cannot be any output. So that is quite clear. Now there also this recursion will be applicable, equally applicable. And then what would happen here? Then it will be obviously n minus, everything will be kind of shifted by the same amount. Your delta input is shifted, delta function is shifted, all the things, its response is also shifted by the same amount. So n minus capital N. Here also n plus, small n plus 1 minus capital N. And here also u of n minus capital N. So time shifted version. Okay, so it is basically a time invariant system. Its coefficients, the coefficient of the differential equation are called constant. They are not time, not a function of time. So that is a time invariant system. And if you apply delta function at any point, any time, or rather in other way, you can say if you shift it by some amount, by some sample, the whole thing, all the response will be shifted by the same in general. So that is true. So anyway, so this is basically in many competitive exam, you will find this kind of problem. This kind of problem where the differential equation will be given in a continuous time domain, and you will be asked to compute that. Whenever you will find the term compute, compute means by using some simulator or software or some machine where you have to do some kind of discretization process. Please note that. So there your approach should be something like this. First you have to do, that means it is implied that you have to discretize that each and every term of the differential equation into its equivalent discretized term or discrete term. And then you do the rest of the mathematics. Fine. Okay. So with this, let's move to probably we have discussed some of the, I think, properties of convolution. I think some of the properties of convolution. Like yes. I probably told, so far I can remember, I told that convolution operation is commutative. Okay, the order is actually material. That means whether you are doing, suppose you have two signals x and y, whether you are writing convolution like this or this is immaterial. Okay, that means keeping this, you are, whether you are shifting this or you are doing that other one, basically the same thing. So it is a commutative. Now this commutative, as I mentioned, it can be mathematically proved. It can be mathematically proved if we just change the variable. It can be proved very easily with this, I think, 1 to 2 lines job. So again, as I've told you before, that you have to consult any book of signals and system for those mathematical proofs, because in exam mathematical proofs may come. The question may be set like that you have to mathematically, suppose you have been asked to prove mathematically that convolution is a commutative operation, or its commutative property, like that. Similarly, it can also be proved mathematically. Again, I will not do it. I'm just going to mention it, that convolution is also associative. Not only commutative, it is also associative. That means, suppose, for example, suppose what I'm trying to say by that, you people know that, but still I have to mention it. Suppose you have one signal V, fine, and it is where you are doing the convolution of V, which suppose you have another two signals, that is W and Y, which are already convolved. And you have the third signal, which this can also be written like, it can also be written like, suppose you first convolve between these two, like V and then after doing this convolution is the other one, that is the Y, suppose in this case. So this is actually your associative property. Similarly, convolution, again, this can be mathematically proved. Again, 2 to 3 steps is required to prove it. Property is again very simple. Here you are convolve the third signal with the added version. That means suppose W and Y, the two signals are already added. This is summation. This is summation. So after adding, convolving with a third signal, and that convolution we add. It's like this.
Sir, your voice is breaking.
So distributive properties again hold. This property also holds. Again, that can be mathematically proved, and you have to do it. Okay. So these properties are actually, why I'm mentioning these properties, because just to just see that in many cases, in many whether I will follow this side or apply this side, depending on the situation. So it may so happen that the left hand side is more favorable than the right hand side, or the vice versa. Voice is breaking. সবাই কেউ মানে সবার ক্ষেত্রেই হচ্ছে নাকি তোমার একা?
প্রবলেম হচ্ছে স্যার।
স্যার মাঝখানে অনেকটাই কথা শোনা গেল না।
কি অবস্থা? হ্যালো।
ইয়েস স্যার।
হ্যাঁ, কি আমার আওয়াজ শোনা যাচ্ছে না?
স্যার মাঝে মাঝে শোনা যাচ্ছে, মাঝখানে কেটে যাচ্ছে হঠাৎ।
মাঝখানে কেটে যাচ্ছে, সে কি গো? সিগন্যাল এখানে তো যথেষ্টই ভালো আছে। ওকে, আচ্ছা কেটে গেলে আমাকে একটু করো, ঠিক আছে?
ওকে।
আচ্ছা, সো ডিস্ট্রিবিউটিভ প্রপার্টি যেটা বললাম, সো ইউ হ্যাভ টু ডু ইট, দ্য ম্যাথমেটিক্যাল প্রুফ আই এম লিভিং অ্যাজ অ্যান এক্সারসাইজ ফর ইউ। You just do it, or as an assignment for you. So this is a distributive property. Again, as I mentioned, which one I should apply, or which side I should use or apply, that depends on the requirement. So this is and the third property, actually no, this is first, second, third. Yes, the fourth. Sorry, the fourth property is it is a multiplication by scalar, any scalar quantity. That is a scalar multiplication. So suppose you have two signals V and W. This is convolved between themselves, and then suppose you are multiplying with any constant A or alpha, whatever. Then it is equivalent to suppose one of the signals is before convolution already get multiplied by that constant. Suppose AV, it's already multiplied. Then after the scalar multiplication, you are doing the convolution with the second signal like this. Or it may be written like this, that P remain intact and I am doing the scalar multiplication to the W by A. So A W, the same thing. So the scalar multiplication, I can do the scalar multiplication after convolution. Whatever the convolved version I will get, I can multiply that by a scalar. So that is equivalent to, but before convolution, I can multiply any one of them and then do the convolution. The same thing. So this is the fourth, I think, 1, 2, 3, 4. Fifth one would be your time invariance nature. So I think the time invariance I have already discussed, that if one of the signals is already time varying, shifted by some amount, then obviously after doing the convolution, the convolved signal will be shifted by the same amount. And if both the signals are shifted, then the convolved version or the convolved signal will be shifted by the resultant of that shifting. That means if one is shifted to the right hand side, another is shifted to the left hand side by the same amount, then effectively your convolved signal will not shift anywhere. It will remain as if there is no shifting operation is done before convolution. So that is related to the time shifting. And another point is that if you already, this is already known, this many times it has been discussed, that if you convolve any signal with a delta function, that means convolution of a signal with a delta function actually leave that signal unchanged. You know that. So that is why in the identity system, I think I have already drawn the picture that Hn is equals to, for the identity system, Hn is equals to delta n. That means whatever input you will apply, you will get back the same input and the output. So that is the identity system. So that is basically convolution of any signal with delta function. So leaves that signal unchanged. So the output is exactly equals to the input. So these are the few properties which we very often use, or we have to use rather, because they're very powerful. And as I mentioned, for each of the properties, there is a mathematical proof, corresponding mathematical proof, which I am leaving as an exercise for you. You just do it, to consult any book and just understand. It's a very simple, nothing complicated there. But again, in the examination, you can expect that you can get one or two properties, the mathematical proof of one or two properties. Okay. And next, suppose, okay, another point I have forgot to mention, that actually convolution, though in some books, I think I have also mentioned that point, in different books, people use the term, or authors use the term convolution sum or convolution integral. So basically convolution integral means the integration for the continuous time case, and sum means the summation for the discrete time case. But as I mentioned, and you are already, I think you people are already satisfied, that convolution is not only related to the one single operation, that is the summation or integration kind of. So it is basically there are multiple operations are there within this convolution operation itself, or the sub operations is there. So even though the sum of the integral or this kind of words are, people use with convolution, but actually that implies the convolution operation of whatever you have learned. Okay, another point is that the properties that I have discussed is actually with respect to convolution operation is equally true for the LTI system, any LTI system, because LTI system, probably I have done a proof for you in the class that how the convolution operations come. So basically the formula of convolution operation, or the way we do the convolution operation, is basically its root is with the properties of the LTI system. So it is the properties of the LTI system that we exploit to find out the expression of the convolution, whose properties are actually the property that I have discussed today, or some properties I've already discussed in earlier classes, So all those properties related to the convolution are basically nothing but the outcome of this exploiting this properties of the LTI system. So that means whatever is true for a convolution, for this operation of convolution, so all will be equally true for the LTI system. That means the properties which are applicable for the convolution are equally applicable for the LTI system. That means all those things, commutative, associative, distributive, the scalar multiplication and types, etc. All those properties are equally applicable for LTI, because the formula of convolution, the way we did the convolution for the LTI system, basically what we have done, or how we have done, or how we have reached up to that point, we reached by exploiting the properties of the LTI system. Nothing, we have done nothing else than that. So we basically done, we have used the properties of the LTI system. So basically it is nothing but analogous to the LTI system, you can say. So all the properties are equally applicable for the LTI system. So if suppose, for example, if any LTI system is given and you have to apply that thing, so don't hesitate. You can say that, okay, no problem, I can easily apply the properties of the convolution here also, equally applicable. Say for example, what I'm trying to say, suppose for example, let's take the example of LTI system. Suppose you have, I'm not taking any numerical example, just a conceptual example actually. So it is one system is H1, another is H2, means impulse response H1, impulse response H2. These two systems, okay, are connected like this. Suppose it is like this. It is connected like this, and we are getting output from here. And your input, we are applying like this. This is X. Fine. Now, tell you what to do. Here, in this, if you follow this branch or this path, if you follow this path, this one, this path. So here, basically, X is getting convolved with H1, and it is producing an output what is called the Y1. And if you follow this path, again, the same input is getting convolved with H2, which is of course a different system, a different impulse response. So again, convolved, and after convolution, whatever you're getting, it's called the Y2. And then Y1 and Y2 are being added, and finally we are getting the Y. This is suppose the LTI system, a particular configuration. That means two LTI systems are connected in parallel, like this. So here, instead of this, I can realize this is equivalent to, I can realize I can apply that distributive property here. The distributive, just now what I have seen for the convolution, same property I can apply. Because ultimately, look at this, operation of all the LTI systems, or dealing with the LTI system, we basically do not apply anything other than convolution. So again, that means in whatever way you explain or argue, so you will reach to that conclusion that all the properties that is applicable for the convolution is equally applicable for the LTI system. So see what we can do here from the distributive property, what you have seen. That means here, what is this? It is Y1 is basically X convolved H1, and this is equals to X convolved H2. And you are adding these two. So which is nothing but, from the distributive property what you have seen, it is nothing but, it is analogous to, like, you have a system whose impulse response, one system, instead of using two systems in parallel, I'm using one system whose impulse response will be H1 plus H2. Just you have these two systems, you just add on this impulse responses and you just apply X, you will directly get Y. So it is just an equivalent to the parallel connection of this LTI system. These are the two LTI systems connected parallel. Here I am using one LTI system which is equivalent to this, where the impulse response of this system is basically addition of these two. In Y2, you can add, you can connect in parallel n number of systems. Why restricted to 2? It is just to give you an example, but in general you can n number of systems. So you just add on. One system is good enough. And again, you can also, that means from in this implementation can be from here to here. So this is given and you can implement it this way. Again, there may be in the reverse path is also true. You can also move in this direction. This is given. You can also break it into different parallel paths or parts or systems. You can do it. Okay. So this thing people often do, this kind of things. So got the sense what I'm trying to say?
Yes.
Okay. Suppose আমি আরেকটু সুবিধার জন্য বলছি, সাপোজ ধরো ফর এক্সাম্পল ধরো তোমাদের কাছে এরকম একটা প্রবলেম আছে, সাপোজ ফর এক্সাম্পল দিস টাইপ অফ প্রবলেম ইজ গিভেন hn ইজ ইকুয়ালস টু একটা কি বলবো, এটা আরবিট্রারি কিছু একটা ধরো না, 1/4, ঠিক আছে, 1/4 টু দি পাওয়ার n un, ফাইন, প্লাস এটা 1/4 করলাম, এটা 4 করে দাও, 4 টু দি পাওয়ার n u of minus. Suppose this is hn. For any system, this hn is given. Okay. Now, suppose the input is suppose xn is suppose un given. Okay. Ja mathay lo bole dilam. Je kono kichu un. Okay. Xn is suppose un. Now you have been asked to find out yn. So in this case, what you will do? It basically you can take this hn as it is. hn form e dewa ache. To be as it is nite paro. It is basically summation of two terms or two individual signals. As a whole, you are getting hn. So instead of two, it may be many things, many signals, many terms rather. So what you can do? You can directly take this and do the convolution. In single convolution process, everything will be done. Or you can break it. Break it means you can take this as a signal and you do the convolution first with un, and again take this as another signal and again do the convolution with the un, same un, and then after doing taking this convolve version from here and here, you just add. This way you can do, and that is actually depends on, as I mentioned, it depends on the application. It depends on what your situation actually demands. If this is the best way to do, it is the optimized way to do, you just do it. If this is not, then don't do it, just break it, follow the other path. It is something like that. Similarly, suppose for example you have two systems like this connected in cascade, what is called the series connection. So in cascade, suppose connected h1 and h2, again two LTI systems, and you are applying x, and at the output you are getting y. So in between you are getting some intermediate output, that is suppose y of 1. What is y of 1? Y of 1 is nothing but your x convolved with h1. And what is y? Y is basically nothing but this y1 convolved with h2, and your y1 is nothing but your x convolved with h1, which is again convolved with h2. So this is the overall form. Now instead of using these two in cascade, what you can do? You can use one single system whose impulse response will be the convolution of these two, h1 and h2. Just convolution. So this kind of cascade interconnection of LTI system can be equivalently be written or implemented like this or drawn like this. So again, why 2? If there may be more than 2, 3, 4, 5, whatever, n number. So basically convolve like this. So one single system is good enough. So you apply x and you will get y. So again, whether you will choose this form or that form, that is up to you. That depends on the requirement, and you have the other factors of the facilities available, etc. Optimization process, etc. So like for example, I'm giving you another example. Suppose probably in this particular context, suppose, okay, what is there on the screen now? Suppose তোমরা সবাই সম্ভবত probably you all are familiar with the bandpass filter. What probably you all know what is bandpass filter is. Now in the bandpass filter, I don't know whether you have designed it or not, because there are many active, if it is implemented by the active components like op-amp, etc. So if you design a bandpass filter, you will sometimes face different difficulties. Not related to the design, means after implementation. Okay, so because the active components are there. Now what happens in the first stage, because in the bandpass filter, in the first stage of the filter is basically, suppose for example, you you have suppose H low pass. Okay, the first stage. The first stage, the impulse response is suppose low pass because it is corresponding to the low pass filter, and obviously that will filter out the high frequency from the input signal. You know that, which is then followed by that high pass. Then after that, what people use H high pass filter, and whose impulse response is H high pass. Suppose, for example, again that actually means with this stage, what we do, we basically filter out the low frequency and the DC components of the input signal. Now these two stages, this low pass, this followed by the high pass, actually these two once, what I'm trying to say is, once these two stages are designed means we know what are the impulse responses for this. That means individually what is H low pass, what is H high pass, etc. Once it is designed, means we know that form, that response, what would be the response like that. So what we can do, we can combine them. We can combine it, like we can do the convolution between these two. If we do the convolution between those two, then what would happen? I will get a single system. Instead of two individual systems connected like this, if I know what is this and what is that, then I will do the convolution operation. And after doing that, I will find out the convolved version of these two. And then I will use one system which can use that convolved version, or whose impulse response will be the convolved version of these two. And you may ask that why. Again, as I mentioned, it may depending on the situation. So in this situation, why I have done this, why I have adopted this path, this method, not this, or prefer to use this, why not the above one? Because please note, this is a op-amp based implementation, or in general any active circuits or active components based implementation. Always remember, whenever you will design and implement, always remember, the less you can use these active components, you are safe, more you are safe. Because your active components are basically a powerful source or the potential source of the noise. So more you can reduce the number, more you can eliminate the noise or rule out the possibilities of noise. Okay, with noise is a very dangerous thing. There are multiple sources, different types of sources are present which can introduce noise in your circuit or system. So you can at least remove some potential or powerful sources of noise, at least by reducing, because if you implement this individually, then obviously the number of active components will be more, op-amps more, suppose. Here in this implementation, when you club this together with just by exploiting this associative property of the LTI system, actually it's the associative property of the convolution. But anyway, I'm talking in terms of a system. There is no difference. You can just see, just try to understand. There is no difference as such. Basically, they are equivalent. The same thing we are doing. Whether we are talking in terms of a system or a convolution, basically all these LTI systems are basically their operation or implementation is fully based on the convolution, success of the convolution operation. So at the background, what is running in the convolution is the convolution. So what is true for convolution is equally true for LTI system. Or in other word, you can say that convolution operation, the way we do the convolution operation, or the expression of convolution operation we derive, we only exploited the properties of the LTI system. So whatever is true for the convolution must be true, have to be true for the LTI system. Okay, clear this thing?
Yes, sir.
Okay. Now, another point, there is sometimes in this context people use the term that is invertibility of LTI system. That is the inverse system. You know, the inverse system. Inverse system is very simple. Just you see, inverse system is, suppose you have a system whose impulse response is H, and you are applying input X, and another system whose impulse response is suppose H1, which is in cascade, and after passing this, you are again getting back this input itself. So input again. So that means what? That means if you just think what is within this dotted box. This box, you have two systems, H and H1. In together, they are behaving in such a way that whatever input we are giving, ultimately getting back the same thing. So input remain unchanged. So this is nothing but your identity system then. Of course, these two together, please note, together will be the identity system. That means I can write from here that H convolved with H1 must give what? Del N. Of course, it has to be. So del N. So whenever the impulse responses of the two systems convolve together will give you delta N, then you can say the one is the inverse of other. One is the inverse system of other. That means here what sometimes in notation wise what people write, if it is Hn, then it is H1 is equals to H inverse N. So this indicates the inverse system. It is a notational representation. So suppose, for example, a simple way, suppose multiplication. If this system is doing a simple multiplication, suppose you are feeding input, it is just multiplying it by some factor and producing the output. So definitely this system will divide by the same factor so that the input remains same. It is something like a very simple example I have said. But anyway, in general, you have to just remember that if this impulse response of this system and this system your convolved together produces delta N, then you can say that one is the inverse of the other. Fine. Again, I'm giving you an example in this context, a practical application. The practical application is something, suppose for example, suppose কি বলা যায়, তোমরা কি কমিউনিকেশন পড়ছো এই সেমিস্টারে? কমিউনিকেশন কি আছে তোমাদের নাকি পরের সেমিস্টারে আছে?
পরের সেমিস্টার।
আচ্ছা ঠিক আছে, আমি এই কনটেক্সটে একটু কমিউনিকেশনের কথাই বলছি। পরের সেমিস্টারে তোমরা ব্যাপারটা মিলিয়ে নাও, জাস্ট টেক ইজ অ্যান ইনফরমেশন, কিছু করার নেই। এই অ্যাপ্লিকেশন বলতে গেলে তো কমিউনিকেশনই আসবে মেইনলি, কমিউনিকেশন বা সিগন্যাল প্রসেসিং। এনিওয়ে, সো সাপোজ ফর এক্সাম্পল আমাদের খুব উই নিড এ ভেরি লো ডিস্টরশন ট্রান্সমিশন of a signal over a communication channel. Over a communication channel means any channel you can take, for example. Suppose for example your TV cable TV তোমাদের সবারই বাড়িতে আছে, ঠিক আছে? কেবল হতে পারে, রেডিও লিংক হতে পারে, এনিথিং লাইক টেলিফোন কানেকশন হতে পারে। ওকে, সো হোয়াট এভার দ্য টেলিফোন লাইন হোক, টিভি হোক, হোয়াট এভার, কেবল টিভি হোক, হোয়াট এভার, রেডিও হোক, for any communication channel you can apply this concept that I need to transmit my signal from one end to another end, from transmitting end to receiving end, kind of with low distortion. That means distortion should be as minimum as possible. That I am trying to maintain. Okay. Now, obviously, at the receiving end, you know, whenever the signal is being received at the receiving end, after passing to the communication channel, after going to the communication channel, when it is received, what is done? It is basically processed to some filter, probably it is processed to some filter. Some filters are there to process. Okay. Now, obviously, again, these are the filters of the systems. So again, these filters have some impulse response. Now, if we design the filters in such a way, that means if design means what? Please note this term. Designing means I can find out what is the impulse response of that system. That means the design is done. If I can find out the impulse response of the system, that means the design is done. So the design means actually I'm looking for the impulse response. I'm trying to find out the impulse response for the system. So if I can find out the impulse response for the system, means here the system is at the receiving end the filters. So such a way that its impulse response will be the inverse of here, this thing. Inverse of the impulse response of the channel. Please note, in the channel, because channel is again a system through which when the signals is going or passing through or passing by, due to different reasons, the signal will be distorted. That means if the impulse response of the channel is known, If the impulse response of the channel is known, that means we know how the signal quality is impaired when it passes through the channel. So if I can design the filter at the receiving end, try to understand the concept. If I can design the filter at the receiving end, whose impulse response will be the inverse of the impulse response of the channel, then of course I can nullify the effects which is introduced by the channel. Okay, so that means this is a possibility. This is a if we can design, then obviously the distortion that occurs during the transmission to the channel will be minimized in many extent, or by large extent it could be minimized. So that is the philosophy behind it. Fine, বোঝা গেল কথাটা? সো এগুলো পরে অবশ্য তুমি যখন মানে এখন হয়তো আমি জানি না তো সেন্সটা বুঝতে পারছো কিনা, যখন তুমি কমিউনিকেশন পড়বে, ধরো অ্যানালগ হোক, ডিজিটাল হোক, পরে স্যাটেলাইট কমিউনিকেশন হোক, টেলিফোন কমিউনিকেশন হোক, তখন বুঝতে পারবে, অপটিক্যাল কমিউনিকেশন হোক, তখন এই জায়গাটা বুঝতে পারবে। মানে অপটিক্যালের যদিও জিনিসটা একটু অন্য, মানে ওখানে তো লাইট থাকে, ওখানে ওই ইলেকট্রিক্যাল প্রবলেমটা কম হয়, বাট এনিওয়ে some kind of losses are also there. So in general, সেই জন্য আমি বললাম যে in general it is true, this concept is true. আচ্ছা, এইবারে তোমাদেরকে একটা প্রশ্ন একটু করি, সেটা হচ্ছে যে ধরো আমাদের কাছে, আচ্ছা তার আগে একটা কথা বলি, তার আগে হচ্ছে যে তোমরা কি এটা জানো যে কোন সিস্টেম যদি বিবো স্টেবল হয় বা হতে হয়, if a system has to be বিবো স্টেবল, what criterion it has to follow? Or বিবো stability criterion?
No sir.
কেন না? কন্টিনিউয়াস টাইম ডোমেন বা ডিসক্রিট টাইম ডোমেনে কোথাও পড়ানো হয়নি এটা?
না স্যার।
ওকে, আচ্ছা ঠিক আছে, তাহলে আচ্ছা এটা আমি তাহলে অন্যদিন বলবো, এটা আমার, আচ্ছা ঠিক আছে এটা আমি অন্যদিন বলবো, এটা আমার এখানে আছে, এইটা এটাই আছে, ঠিক আছে, এটা আমি যদি সময় হয় আজকে বলবো, না হলে পরের দিন বলবো, ঠিক আছে, পরের দিন বলবো, বা আজকে যদি সময় হয় তাহলে। তার আগে তাহলে আরেকটা জিনিস একটু আমি কমপ্লিট করি। আচ্ছা, সেটা হলো যে তোমাদেরকে আমি কনভলিউশনের কোনো অ্যাসাইনমেন্ট বা প্রবলেম কিছু দিয়েছিলাম বাড়িতে করার জন্য, বা কিছু বলেছিলাম?
হ্যাঁ স্যার।
কি দিয়েছিলাম বলো তো?
স্যার একটা প্রবলেম ছিল, একটা গেট ফাংশন আর একটা র্যাম্প ফাংশন, সেই দুটো গ্রাফিক্যাল মেথডে কনভলিউশন।
আচ্ছা, আর
একটাই মানে দুটো কোশ্চেন ছিল, একটা হচ্ছে গেট ফাংশন মানে র্যাম্প ফাংশনটা জাস্ট ওই রেঞ্জ গুলো চেঞ্জ করে গেট ফাংশনটা,
ওই র্যাম্প ফাংশনটা মনে পড়েছে, মানে ওটা আলটিমেটলি তোমার একটা ট্রায়াঙ্গুলার পালস হবে, তাই তো? একটা ট্রায়াঙ্গুলার সিগন্যাল।
হ্যাঁ স্যার।
তো হ্যাঁ বুঝতে পেরেছি, ওটার ওই তোমার একবার উইথটাকে ওই আমি একটা করালাম, তার এগেইনস্টে দিয়েছিলাম, তাই তো? দুটো, হ্যাঁ বুঝতে পেরেছি মনে পড়ে। ওকে ঠিক আছে, আজকে আরো দুটো দিচ্ছি, এই দুটোকে ওর সঙ্গে অ্যাড করে নাও। আজকের প্রথম প্রবলেমটা হচ্ছে, সাপোজ আমাদের কাছে এগেইন আমি তোমাদের ম্যাথমেটিক্যাল ফর্মটা নেব, I will not draw the signals, okay? I will not sketch the signals, so I will just write the mathematical form and you have to first sketch the signal and then you have to do the convolution by using graphical method. আমি strictly বলে দিচ্ছি, using graphical method you have to do it. the first signal is, suppose for example, we are interested to find out yt of a continuous time LTI system whose impulse response is means the ht is, suppose ht is e to the power minus t minus 1. ভালো করে উল্টো পাল্টা লিখো না, কিন্তু যেটা লিখছি ঠিক মতো লিখো, u t minus 1, otherwise आंसर উল্টো হয়ে যাবে। ঠিক আছে, ht, the impulse response of a continuous time LTI system is e to the power minus t minus 1 into u of t minus 1. Okay, this is ht, and the input signal that has been applied, that is xt, is ut minus of u of t minus 3, t minus 3. Okay, this is the input, this is the impulse response for the LTI system, and we are interested to find out the yt. So again, we have to do the convolution, but first you have to draw the corresponding pictures on the waveforms for ht and xt, and then you do the rest of the operations. Okay, please note, you have to apply graphical method, that is step by step, graphically. The pictures you have to draw different steps or ranges, whatever you will take. Depending on that, you have to draw some pictures like that. Okay, so show the overlapped portion, etc. So graphically you have to do the first thing. The second problem, number 2, এটা কি থেকে দেওয়া যায়, এটা ডিসক্রিট দেব না কন্টিনিউয়াস দেব? আচ্ছা ঠিক আছে, কন্টিনিউয়াসই থাক, কন্টিনিউয়াসই দিচ্ছি তোমাদের। আচ্ছা, আরেকটা সিগন্যাল দিচ্ছি, সাপোজ এগেইন একটু ভ্যারিয়েশন আনি। Again, the impulse response for the LTI system is suppose ht, which is suppose u of t plus 1, u of t plus 1, please note it, u of t plus 1, and your xt is minus e to the power, কি বলা যায়, minus e to the power minus e to the power 2 t minus 1 u of t plus 1 বলেছি তো, এটাকে এরকম করো, minus t minus 1. Okay, xt equals to minus e to the power 2 t minus 1. Okay, u minus within bracket t minus 1. Okay, so again, impulse response for the system and given input signal this, so again you have to find out the yt, the output, using graphical method, of course. So this two, again, I am giving as an assignment. You just do the step-by-step method. You draw the corresponding picture, the figure, the relative positions. Wow, means after flipping, after in some, you have to capture some intermediate steps while shifting one with respect to the others, and then the overlap portion you have to mark corresponding to the ranges concerned, and from that you just have to, to draw. And of course, you have to draw at the end, you have to draw the output of the output waveform. That means first you have to find out yt. So again, the mathematical form, and as well as you have to draw the picture of yt. That means a waveform you have to draw, both the cases. Okay, this two. Again, I have just to add this to the previous day's problem. ঠিক আছে?
Yes, sir.
Okay. তাহলে আমি স্ক্রিনটা ইরেজ করলাম। ওকে, এবারে আমরা যে স্লাইডটা আমার কাছে খোলা ছিল আগে, সেটা আমি একটু বলে দিই, তারপরে আমি ওই পার্টটা আসবো, যেটা তোমাদের কাছে তোমরা জানো না বললে। আচ্ছা, এখানে দেখো আমরা এক সেকেন্ড, কনভলিউশনের কনসেপ্ট আমাদের মোটামুটি একটু তৈরি হয়েছে, কিন্তু আরেকটা অপারেশন আছে যে অপারেশনটাকে বলা হচ্ছে ডিকনভলিউশন। ডিকনভলিউশন নাম থেকে বুঝতে পারছো বেসিক্যালি এরও কিছু অ্যাপ্লিকেশন আছে অবভিয়াসলি, বিভিন্ন মেজারমেন্ট টেকনিক্সে আমাদের কাজে লাগে। সাপোজ ফর এক্সাম্পল, মানে ইন জেনারেল আমি যদি বলি, সাপোজ we have the knowledge of HN, and we know what is the output, suppose for example, but we don't know what is the input. We don't know what is the input. Now output is known, impulse response is known, but we don't know the your input. So in that case, basically we do the operation that we take the help of is called the deconvolution. It's basically the same convolution. Deconvolution, but as you understand that it is bit coming, the concept is coming from the convolution actually. Now how to implement that? Let's start with the formula of the convolution. Okay, this is the well-known formula of the convolution, that is y in summation of this. Now that, for the sake of simplicity, you just assume that these two, this yn and hn, these two are known in this case, but this is not known. We have to find out this. So these two are basically one-sided finite sequence signal. So one-sided finite sequence signal. Now, so the limit will change like this. Okay. Now here I can write my y0 when you put n equals to 0. So y0 will be nothing but your x0 and h of 0 for n equals to 0. Now when n equals to 1, of course it will be y of 1, and then it is nothing but when n equals to 1. So n equals to 1, there will be two terms. Please note, two terms. The first term for the k equals to 0. Then for k equals to 0, if you put k equals to 0, then it will be x of 0, and here n is 1. So 1 minus 0, 1. So x of 0 and h of 1. Look at this. This one. X of 0 and h of 1. And the second term when k equals to 1, because the maximum value of k is n, so it will can at most maximum can reach up to 1. And here n is 1. So when it is 1, 1 minus 1, 0, and it is 1. So x1 h of 0. Fine. For n equals to 1. Similarly, for n equals to 2, then k will run from 0 to 2, that means 0, 1, 2, 3. So 3 terms will be there. So again, you just put the values of n and k, you will get these three terms. So again, if you write it in terms of a matrix, so the matrix would look like this. You see just a matrix of the output, one column matrix. Again, that is a y0, y1, y2, in general, so on, and many more. And here, this is again another column matrix. This corresponds to the inputs x, and this matrix is basically corresponds to, or the terms in the matrix is basically coming from the impulse values of the impulse response at different values for different values of n. So here it is h of 0 and rest of the terms of 0. Here it is h of 1 and h of 0 and rest of the terms are 0. And similarly like this, and so on and so forth. So that means here in terms of the matrix, I can write y equal to h of x. So definitely that implies that what is x? Because I'm interested to find out x. But x is not known to me. So x is basically h inverse y. So I have to go for the inverse, find out the inverse of this. Now again, this is just a representation. You don't have to bother too much because it's just a matrix representation. But what do we actually do? You just, if you look at this individual expressions for y0, y1, y2, etc. So we know y0, we know h0, we don't know x0. So how to find out x0? X0 is nothing but y0 by x0. X0 is nothing but y0 by x0. So here, this is quite clear that x0 is y0 upon x0 or h0. Similarly, in finding y1 is known, but I don't know what is x of 1. But I know what is x of 0. I know what is h of 0. I know what is h of 1. I know what is x of 0. From where I got it? I got from the previous step. X of 0. Now, if I plug in here, I will find out x of 1. Similarly, in the third step, to run this third step or to find out the value of y2, y2 is known, y2 is known, to find out the value of x2, then I know y2, I know h2, I know x0 from this step, I know h1, I know x1 from this step, I know h0. Just I will plug in all those values, I will find out x2. So in general, these forms can be written. y1 equals to this, which implies x1 equals to this. Again, y2 equals to this, like this. So in general, xn equals to, basically, if you follow the individual terms, it is basically yn minus summation 0 to n minus 1. One term less. Xk h of n minus k divided by the h0. h0 is always in the denominator. Always. So this is the general formula of finding the xn. Now you just see the formula. If you have the values of xk's and the values of hk's are known, then if you plug in, you will find out the xn. You'll find out the xn. So a typical example is this. So again, I'm giving it as an exercise to you, that yn equals to this and hn equals to this. Now, impulse response is given, output is given. So I'm interested to find out the input, xn. So you just apply this formula and you will find out. Very simple, very simple. Now you just note one thing here. Ultimately, you are using the convolution, but in a bit different way. You are applying bit tricks in using the convolution, because you know one side, the another side is not known. So expected output is known, but the input is not known. So basically, you are doing a bit twist with it. So here in this operation, you just see yn. What is the length of the yn? 1, 2, 3, 4, 5, 6, 7. This is the length of the output. And the length of one of the inputs, that means hn is one of the inputs actually. So 3. So we know the formula that actually the output should be one sample less than the summation of the length of the two individual inputs. So obviously, if the output is 7 and one of the length of one of the signals is known, that is 3. So of course I know what will be the length of my other input, that is here in this case the xn, and that would be nothing but 5. So the length of the input would be 5, that we know. And you just apply this formula. It is a general, or individually you can find out the values like this. So y0, y1, y2, like that. So you just find out to plug in the values of x, h, and y, and you will find out x. Very simple. But that is a very powerful operation, because that comes from the convolution, but because that is after all based on the convolution. But the name of this operation is called the deconvolution. Okay, deconvolution. Here in this case, also please note that as a corollary of this operation, I can also tell you another thing. That suppose, for example, তোমরা তো সার্কিট সিনথেসিস করছো না, তোমাদের সার্কিট থিওরি এন্ড সার্কিট অ্যানালিসিস এন্ড সিনথেসিস দুটোই আছে তো। তো সিনথেসিসে তোমরা কি করো? সিনথেসিস যখন করো তখন বেসিক্যালি তোমরা কি করো? ইউ নো দ্য আউটপুট, ইউ নো দ্য ইনপুট, বাট ইউ ডোন্ট নো হোয়াট ইজ দ্য সিস্টেম। ইউ হ্যাভ টু basically তোমরা কি করো? You have to find out the hn or ht of that system. Now the point is here also, look at, in some sense it is also giving you the flavor of that synthesis. Why? Because you just see the same, this operation can be viewed like here what I have told, that this is known, output is known, one of the inputs is known, the other is not known. And the other means I have specifically mentioned the x, but there is no secret behind this x. You can also take h also, that h is not known. You know x, you know y, but you don't know what is h. That means what is there inside the system, what is the impulse response, you don't know. It is like a black box, you are feeding and you are getting. But what is there within, I don't know. That means I don't know about the design or the characteristics of the system which is giving this output upon applying this input. So I can find, with the help of this deconvolution, I can also do the same thing. The same concept, the same formula. Here instead of finding the x of 0, you have to write h of 0. H of 0 will be y of 0 divided by x of 0. Similarly, here also, you have to find out the h of 1. H of 1, and you have all the terms known. H of 0 we are getting from the first term. You just plug it, you will find h of 1. Here also, you can find out easily h of 2, because all the terms are known, either given or from the previous steps, and you just plug in, and you will find out h of 2. And in this way, you can do the operation, and you will find out all the values of the h, all the h's, rather, you can find. That is a whole pattern, you know. This is a very beautiful, very, very powerful operation in finding out the impulse response of the system. So that is kind of a synthesis. Got the point? So that is why deconvolution is so powerful and so important. Okay. আচ্ছা, আমরা তাহলে একটা কাজ করি। তোমরা যখন বললে ওইটা পড়ানো হয়নি, জাস্ট আ মিনিট দেখি এটা।
স্যার একবার বিভো স্টেবিলিটি বলবেন বললেন।
ওটাই ভাবছি যে আমি এখন বলবো না পরে বলবো। আমার কাছে স্লাইডটা রয়েছে এখানে। তা আমি অ্যাকচুয়ালি প্ল্যানটা আমি জানতাম তোমরা জানো, তো বাট স্টিল আমি ঠিক আছে, আমি স্লাইডটা যখন আছে আমি দুটো জিনিস একটু বলেই দিই। অ্যাকচুয়ালি এটা আমার প্ল্যানে ছিল না আজকে, বাট এনিওয়ে আমি দেখছি আমার কাছে স্লাইডটা রয়েছে, তো আমি জাস্ট তোমাদের একটু তাহলে একটা দুটো জিনিস একটু জাস্ট এই কনটেক্সটে একটু বলে দেবো। হ্যাঁ, একটা কজালিটির ব্যাপার আছে, আর একটা সম্ভবত দাঁড়াও এটা কিসের স্লাইড একটু দেখে নিই। Okay, it is related to the causality. Okay, I think the second one is related to the stability. Yes. Okay, আমি বলে দিচ্ছি, এখন বলে দিই। আমার কাছে রেডি রয়েছে, আমি পরে দিয়ে জন্য রাখছি না। আচ্ছা দেখো, আমরা কজাল লিনিয়ার টাইম ইনভ্যারিয়েন্ট সিস্টেম, এই জায়গাটা আবার কনসেন্ট্রেট করো। কজাল লিনিয়ার, বা যখন আমি টার্ম গুলো বলছি বা কোয়ালিফায়ার্স গুলো বলছি, তোমাদের মাথার মধ্যে ঢুকিয়ে নাও তাদের প্রপার্টিস গুলো, তাহলে বুঝতে সুবিধা হবে। কজাল linear, LTI তো আমাদের সব সিস্টেমে LTI in general unless otherwise mentioned, but here specifically আমি causal কথাটা এখানে মেনশন। আচ্ছা, তোমরা স্ক্রিনটা দেখতে পাচ্ছ বাই দ্য ওয়ে? এটা কি দেখতে পাচ্ছ নাকি আমি অন্যভাবে খুলবো এটাকে?
স্যার একটু জুম করলে ভালো।
জুম করলে ভালো হয়। এবার
হ্যাঁ স্যার, ঠিক আছে। ওকে।
আচ্ছা দেখো, this for a causal LTI systems ভালো করে বুঝবে। আবার বলছি, causal LTI system মাইন্ডসেট করে নাও, আগে টিউন করে নাও প্রপারলি। The causality properties, linearity and time invariance properties hold simultaneously. So output at the time, output at any suppose time in term n, suppose it only depends on what? On the present and the past input, but you know that it doesn't depend on the future inputs. You know that quite well. That means, in other words, I can say that output of the system at some time interval, instant, suppose n, any time instant n, suppose for example, say n equals to, according to the slide, suppose n equals to n0, suppose n equals to n0. It depends only on the values of the xn. Please note, only on the values of the xn for n less than equals to n naught. n naught টা বললাম that a specific value জন্য সুবিধা হবে, যেহেতু স্লাইডে লেখা আছে according. So n naught, n less than equals to n naught জন্য যে ইনপুট গুলো থাকবে তাদের ভ্যালুর উপরে ডিপেন্ড করবে। ফাইন, এটা হলো। এইবারে তাহলে ব্যাপারটা হচ্ছে, ধরো সাপোজ ইন কেস অফ এন LTI সিস্টেম, this causality, this definition of the condition of the causality can be translated, you can say, to the condition of impulse response. So the condition of causality can be translated to the impulse response, or the condition of impulse response. That means I can, in terms of the impulse response, I can define the causal definition of a causal system. আমি অলরেডি তোমাদের বলেছি, বাট এটা একটু সিস্টেমেটিক হচ্ছে, একটু রিগোরাস ম্যানারে বলছি, ঠিক আছে? বিকজ অলরেডি দিস ইজ নোন টু ইউ, আমি বলেছি ক্লাসে, কিন্তু এটা একটু সিস্টেমেটিক ম্যানারে বলছি, মানে তোমরা ভেবো না আমি কোনো রিপিট করছি, ঠিক আছে? কিন্তু দেখো আমি বুঝতে পারবে, পুরো প্রসেসটা বললে বুঝতে পারবে আমি কি বলতে চাই। সো বেসিক্যালি দ্যাট মিনস That means what? Let us suppose consider an LTI system, having an output at time. Suppose here this n equals to n0, and that is by convolution can be written like summation k equals to minus infinity to plus infinity h of k x of n naught minus k. Fine, that is by definition I can write it. Now I can subdivide the sum into two sets of terms. Just look at the second step. One set involving the present and the past values of the input. Please note the present and the past values of the input, and that means xn for n less than equals to n naught. N naught is kind of like a pivot to us, reference point to us. Okay, so n naught less than or equals to n less than or equals to n naught. That means the present and the past values. And the other set involving only the future values. Please note, only the future values. That is xn for n greater than n naught. And you just see the two terms that is written. Summation, summation k equals to 0 to infinity. Now, if you put k equals to 0, it will be x of n naught, h of 0. If you put k equals to 1, it will be n naught minus 1. Please note, n naught minus 1, h of 1. If you put 2, n naught minus 2, x of 2. Okay. Similarly, here also, suppose if you put k equals to minus 1, then it will be h of minus 1, x of n naught minus of minus. That means plus 1. Are you getting the point? X n naught plus, that means the future. This part, future, n naught plus. If you put n equals to minus 2, that is n naught plus 2. That's the future. And here it is basically that 0 means the n naught, the present, and or n naught minus 1, minus 2, minus, and all the past. So this part, this set, I have divided into two subsets. This set actually corresponds to the term of the input that is involving the present and the your past values, and here only the future values of the input. Is it okay up to this? Now what we are doing here, we are basically, this summation is kind of written like a term by term. Okay, this is a compact expression. Here we have actually written each and every term like this. So that means the whatever I mentioned actually, the h naught, x of n naught, h1, x of naught, like this, and here h of minus 1, x of this. Okay, so এটাকে আমরা expand করে দেওয়া লিখেছি, এরকম মনে হচ্ছে জিনিসটা হলো, এটা লেখা হলো। এইবারে তাহলে এবারে এখান থেকে ভালো করে দেখো, দুটো সামেশন আমি তোমাদের সুবিধার জন্য এইভাবে ভেঙে দিয়েছি, লিখে দিয়েছি এখানে। তুমি যদি এটা ভালো করে লক্ষ্য করো, দেখো, if you observe the terms, the first sum within the first bracket মানে first term, sorry, এইটা বলতে চাইছি, ঠিক আছে? ফার্স্ট টার্ম মানে এই পার্টটা বলতে চাইছি। ঠিক আছে, the first term actually, if you observe it carefully, this first summation involves actually xn naught minus 1, n naught minus 2, and so on. As I mentioned, these are nothing but the present and the past values of it. But in the second summation, this part actually your x n naught plus 1, n naught plus 2, etc. So those are the future values of it. Now the point is, now if the output at time n equals to n0 is to depend only on the present and the past inputs, then clearly the Hn of the system must satisfy this condition. Output of the system at any time n equals to n0, because n equals to n0 is a reference time here in this analysis. So n equals to n0 is to depend only on the present and the past inputs, because by definition we know, by definition of the causal system we know that it has to depend on only on the present and the past inputs. It cannot depend on the future. So then obviously you know that this coefficient has to be 0. Hn with the negative argument has to be 0. Otherwise, this term will not vanish. This term will only this terms will retain, and this term will vanish. So now to make the whole term, all the summation vanish, make it 0, this individual coefficient, this h of -1, h of -2, h of -, etc., has to be 0. It has to, that means in general they has to satisfy this condition. Look at this, h of n equals to 0 when n, that is within the argument, whatever is there, is less than 0. That is -1, -2, -3, so on. So from here, this is the rigorous way to prove it. It is a rigorous way to prove it. Now, since got it, so since Hn is the response of any relaxed LTI system to a unit impulse applied at n equals to 0, now it follows this thing that Hn is 0 for n is than 0. This is both the necessary within the red box, whatever is written, this is the necessary, as well as the sufficient condition for causality. This is the necessary as well as the sufficient. That means this is the, that means, for example, what I'm trying to mean by the necessary and sufficient. That means, suppose for the case of a linear system, what is the necessary condition? Necessary condition is it has to satisfy the homogeneity principle. But the satisfying homogeneity principle is not sufficient, because if any system is homogeneous, there is no guarantee that it is linear. It has to satisfy the superposition. So two, you can say, means homogeneity and superposition, you can say in this way they are the necessary and the sufficient condition. Here there is no second condition, if and only if this is true. That is, in other words, I can say that your LTI system is causal, will be causal, if and only if its impulse response is 0 for negative values of n or for negative argument. It is also true for the continuous time. Yes, the same concept. Here instead of summation, there instead of summation, to do the integration. That's all. So the same concept. So the impulse response, if the impulse response is 0 for negative value of argument or negative argument for any LTI system, that LTI system is bound to become causal. This one condition is necessary as well as sufficient, both. So you don't need to depend on any other conditions. Okay, so this is a rigorous way to prove it, actually. Now, other fact, I think these two things have already been discussed. This part, if your system is causal or the signal is causal, then what is the restriction we have to impose on the limits? Okay, this thing, how the limits will be modified, these things have already been discussed, I think. So that is nothing new, but means these two things are already known to you. Okay, so this is the point. And that means actually here you just need to know one thing, that causality actually is required in any real-time signal processing application. Since I already mentioned this point, but still I'm giving it a stress that since at any given time in, we have no access, we have no control on the future values of the input signal. What is going to come next? What is about to come next? I cannot predict. My system cannot predict. Only the present and the past values of the input signal which are already available, and only based on that I can do the computation of the present output. That much I can do. But real-time signal processing, real-time, please note, signal processing with the hardwares, it is not possible, as I have mentioned several times in the past in the class. Okay, this is another time I have mentioned in this context. Anyway, so this is about the causality. Now, another thing, another picture is already drawn here. Please note it, that here sometimes you may get confused with the negative value of the argument. Sir, negative value of the argument is 0 actually doesn't make sense. It means actually it makes sense. If you look at this, look at these two figures or that their relative actually positions. I have used different colors to indicate the different samples actually. So the values are all same. That suppose this is a particular pattern of Excel. Okay, and you just concentrate or focus on any particular color which corresponds to the sample at the present instant. Suppose 0. It is a present sample. And all these negative samples, the samples at the negative left-hand side, they all are the, the past samples. And all those at the right-hand side, they are the future, that is about to come, yet to come. Okay. Now, suppose if you want to give it a shift means look at here. If you want to make it xn, if you want to make xn plus 1, that means at n the signal, this signal will be true, or this signal means all the individual samples, all the samples individual will be true for n equals to minus 1. This argument, if you make it n equals to n plus 1 equals to 0, then your n equals to minus 1. That means here, every sample will be shifted to the left-hand side by one unit. Each and every sample by 1 unit. That means what is supposed to be there at n equals to 0 is now at n equals to minus 1. Please note this. What is supposed to be there at n equals to 0, what is supposed to occur. You can also designate these things as an individual incident, individual occurrence. So what is supposed to occur at n equals to 0, what is supposed to happen at n equals to 0 is happening at n equals to minus 1. How this could be possible? Because this is the present. It is supposed to happen here now at this point, but it is happening at the previous time instead, some time before. How this is possible? This is the implication. So when you are shifting it to the left-hand side, that is why in the very first day or second day I told you that this advancement, this is kind of advancement. This is kind of advancement. You are advancing the signal. So advancement means, in other words, look at here, this yellow signal, this yellow bar is supposed to come here at this point or occur at this instant. But it is occurring here. That means it already occurred. That means, in other words, I can say I have already sensed that. I already know what is going to come here. I already know at this point. How this could be possible? This is not possible. So that is why this negative arguments means this thing. That this negative means this negative. It is not possible. So this -1, -2, -3 implies that after shifting, please note, this negative doesn't mean this negative. This negative means if you give any pattern you have, if you want to shift it, if you want to advance it, then what would happen? The present instant will go to the immediate past instant. The past to the past, actually, 2 samples before, like this. So all are basically getting advanced by 1 sample to the left-hand side. That is the meaning of this negative argument. So here, suppose this -1 means what? If you put n equals to -1, suppose h of -1. This is precisely 0 for n less than 0. That means what? H of -1, say for example, should be 0. Otherwise, if it is not, then that means it can get this pattern. The system can produce this pattern. And if it can produce this pattern, that means, in other words, we can say the system can predict what is supposed to come at n equals to 0. It's coming, it knows, or it can anticipate that what is coming at the immediate previous instant, which is not possible. That is kind of a prediction kind of thing, or anticipation kind of thing. That is not possible. So this pattern, you cannot follow this pattern or cannot implement this pattern. So this is the point. Anyway, next একটা কি বললাম যেন, স্টেবিলিটি না? আচ্ছা, বিভো স্টেবল মনে আমি কিছুটা তোমাদের একটু বলেছিলাম, অল্প স্বল্প, তাই না? একদিন একটা কোনো একটা ক্লাসে বিভো স্টেবল এইটা দেখে আমার মনে পড়ছে কিছু একটা বলেছিলাম তোমাদের বিভো স্টেবিলিটি নিয়ে। যাই হোক, সো today
স্টেবিলিটি সম্পর্কে বলছিলাম।
হ্যাঁ, স্টেবিলিটি সম্বন্ধে একটু বলেছিলাম, মনে আছে।
সিস্টেমের আউটপুটটা যদি কন্ট্রোল করতে পারি তাহলে সিস্টেমটা স্টেবল, এরকম করে কিছু একটা বলছিলাম।
ওকে, ঠিক আছে, যাই হোক, ঠিক আছে। আমি আজকের এই কন্ডিশনটা মানে মেনলি আমাকে বলা দরকার হচ্ছে এই কন্ডিশনটা। এনিওয়ে, যেটা আমি বলতে চাইছি যে suppose you have any relaxed system, okay, which is said to be Bibo stable if and only if your output is bounded, output sequence for all the values of the n, yn for all the values of the n should be bounded if your input is bounded for all the values of n. That means for each bounded input or bounded values of input, your output is bounded, your system is Bibo stable. So that means if xn is bounded means, look at this, mod of xn, the absolute value I'm taking, should be equals to less than or equals to mx. Mx is a finite number, any finite number, which is of course less than infinity. In this context, as you can understand, it's quite implied, which is less than infinity. Okay, it's mx. And that is true for all n. That is all the inputs, each and every input of this sample for this signal. Okay, this is true. If this is true, then output means y of x. Sorry, এটা আমি x লিখেছি, এটা একটু ভুল হয়েছে, এটা n হবে। ওকে, এটা একটু কারেক্ট করুন, এটা y of n হবে। ওকে, so y of n, mod of n should be less than equals to, again, suppose m of y, and again m of y may be another finite number which is less than infinity, of course, and that will be also true for all the values of n. That means every sample in the output must follow this condition. If this happens, then my system is Bibo stable. That we know. এইটা আমরা কিন্তু জানি, আমরা অলরেডি ডিসকাস করেছি। আজকে আমরা এগেইন যেটা আমি বললাম আগের দিনে, এই একটু আগে যেটা ডিসকাস করলাম, যে কন্ডিশন অফ দ্য কজালিটি ইন টার্মস অফ দ্য ইনপুট আউটপুট translated to the condition, how it is translated to the condition of impulse response for the system. Become the hn should be 0 for n less than 0. That is the translated, how it is translated. The condition was between the input and output. Now, how it is translated to the condition of the condition related to the impulse response of the system. From the perspective of causality. Now this is from the perspective of stability. Okay, again a LTI system which has to be stable. And how the condition between the input and output, this thing will be translated to the condition of impulse response for the system. That we are trying to understand here through this slide. Okay, now just look at here. Now basically, given such a bounded input sequence xn to this, suppose in the LTI system, now we know that we can write the expression of convolution. So what is written over here? Yn equals to summation k goes to minus infinity plus infinity hk x of n. So that's the famous equation we all know. Now if we take the absolute value of suppose at both the sides, here it is written at both the sides, if we take the absolute value here as well as here, we have to take the absolute values, then we can write like this, right? Now you know from your mathematics, full mathematics, you know that the absolute value of sum of the terms is always less than or equal max to the sum of the absolute value of the individual terms. You know that. So this can be written like this. Got the point? How we have written this from this line? This is, what is this? This is basically the absolute value of the summation. A summation. There are different terms we have summed up and we got absolute value. We find the absolute value. And this absolute value of the sum of terms is always, less than or at least at max, equals to the sum of the, that absolute values of the individual terms. Here you just see absolute values of the individual terms. After doing the absolute, finding the absolute value, you are doing the summation. So this is this is always, either less or at max it is equal. So that is why it is written like this. So if the input is bounded, obviously there exists a finite number mx such that the mod of xn should be less than mx, that you know. Now if we substitute this upper bound of xn equation here, if we substitute, then what we will get? We will get this thing. Just if mod of xn less than equals to, look at this, this is x of mod of xn minus k. Now if we just this condition, this value mx, suppose is the maximum value, suppose for example maximum, and all the values are less than that. So if we just substitute here, so what would happen? This will basically come out of the outside the summation sign, and then I can write the expression like this thing. Now here under this condition, the output, where the output will be bounded, just observe carefully. Your output is bounded if because this is already bounded from this condition. I've just used this condition here and I got this expression. So I don't have any problem with the mx. I don't have any problem. But the point is, what about this? Now this will be bounded only when this thing, this whole thing where I am basically moving my cursor, this thing is bounded. That means what? That means this condition is held. That is summation mod of hk, summation over from k equals to infinity to plus and minus infinity to plus infinity mod of hk is less than infinity. When this is true, then your output must be bounded and the system will be Bibo stable. So look at how the condition of regarding stability, Bibo stability between input and output, the conditions of input and output is translated to the condition of impulse response. Just by looking at the impulse response, you can say whether it is bounded or not. Your system, whether your system is bounded or not. Whether that means I mean to say whether the system is stable or not. If this is true, then your system is stable. Output will be bounded given a bounded input. But if it is not, then no question. Again, this condition is necessary as well as sufficient. It is not only necessary, it is also sufficient. That means there is no other condition. If this is satisfied, you can blindly say that my LTI system is my LTI system must be stable. That means in the examination, the question may come like this. Suppose I can cite a statement. I can write a statement. I can give a statement like, suppose in the previous case I have mentioned, for the case of causality, here also I can mention, suppose an LTI system is stable if and only if its impulse response is absolute. This is called the absolute summability. This is absolutely summable. Absolute summable. You just prove it or justify this. So you have to do these 2-3 steps with proper justification. Okay, so that is the thing. In case of causality, I mentioned. Here also in case of stability, I mentioned the condition. The condition is you have your impulse response for the system will be absolutely absolutely summable, and the counterpart, the continuous time counterpart will be the integration. Here instead of summation, that will be integration. So the integration will be absolute integrable. That means here it is the absolute summable impulse response. In the continuous time case, it will be the absolute integrability. The system will be absolutely integrable. If it is true, then your system is Bibo stable. Got it? Got the point? So if this is okay, then suppose I'm going to give you an example. Suppose আচ্ছা, এটা আমি তোমাদের ইয়ে দিচ্ছি না, মানে আর হোমওয়ার্ক দিচ্ছি না, মানে আমি তোমাকে এখনই ডাইরেক্টলি জিজ্ঞেস করছি, ঠিক আছে? মানে হোমওয়ার্ক তো অনেকগুলো হয়ে গেল, তাই তো অলরেডি, তো আমি আর এটাকে হোমওয়ার্ক হিসেবে দিচ্ছি না তোমাদের, আমি ডাইরেক্টলি এখনই মানে ক্লাসে তোমরা এখনই আমাকে বলো। আমি তোমাদের দুটো ইয়ে দিচ্ছি, একটা এক্সাম্পল দিচ্ছি সিস্টেমে। ধরো ফর এক্সাম্পল প্রথমটা হলো ডিসক্রিট টাইম, ফাইন। ডিসক্রিট টাইম সিস্টেম impulse response hn, which is equals to suppose 1 by n u of n minus 1. Fine. Discrete time system having impulse response hn equals to 1 by n u of n minus 1. Now just tell me whether this system is Bibot stable or not. মানে জাস্টিফাই করো যে Bibot stable হবে কি হবে না।
So 1/n তো ডাইভারজেন্ট, তাহলে হবে না।
ভালো করে দেখে বলো। 1 by n into u n minus 1. তুমি কি n এর ভ্যালু 0 পুট করেছিলে বললে নাকি অন্য কোনো সেন্সে বলছো? n এর ভ্যালু 0 কি? আচ্ছা এই লিমিটটা কোথা থেকে হয় বলতো, সামেশনের লিমিটটা?
So 1 to infinity.
1 to infinity, very good. 1 to infinity. 1 to infinity. আচ্ছা বেশ, 1 to infinity, ঠিক আছে, 1 to infinity। এবার বলো 1 by n, তাই তো? 1 to infinity 1 by n, বা যাই হোক মানে এরকম ভাবে বলা যায়। আমি যেটা বলতে যাচ্ছিলাম আর কি, যে লিমিট n ক্যাপিটাল n টেন্ডস টু ইনফিনিটি summation n equals to 1 to capital N 1 by n, ঠিক আছে? এটা তো ব্যাপার। এই সামেশনটা কি কনভার্জ করে না ডাইভার্জ করে? ফার্স্ট টার্মটা কি পাবে? 1 পরের টার্মটা হাফ, তারপরের টার্মটা
1/3
1/3 1/4 1, তাই তো? এটা কি হয় ছোটবেলায় করেছো?
কনভার্জ করে।
ছোটবেলায় করেছো? এ দেখো এবার তার অ্যাপ্লিকেশন। এই ডাইভারজেন্সে তোমার ইয়ে কবে ছিল? সিরিজ কনভার্জ করবে ডাইভার্জ করবে, এটা কি তোমরা এইচএস এ করেছো না এটাই করেছো, বিটেএ করেছো?
না স্যার, ফার্স্ট সেমিস্টারে
করেছো। ওকে,
ফার্স্ট সেমিস্টারে।
আচ্ছা তো যাই হোক মানে তোমরা জানো আর কি, এটা আমি বলতে চাইছি। হ্যাঁ এবারে বলো এটা কনভার্জ করবে না ডাইভার্জ করবে?
স্যার 1/n তো ডাইভারজেন্ট হয়।
কেন হয়? প্রুফ করতে পারবে? মানে আমি তোমাকে যেটা বলতে চাইছি, মানে সেটা তোমরা প্রুফ বা টেস্ট মেথড গুলো তো তোমরা, আমার মনে হয় তোমাদের মনে আছে অনেকেরই যে টেস্ট মেথড গুলো ছিল। তো আমি অত রিগোরাস ওয়েতে যাচ্ছি না, হ্যাঁ সেগুলো তো ম্যাথামেটিক্স এর ব্যাপার, আমি ওখানে যাচ্ছি না। বাট যদি পরীক্ষায় আসে, ইন এক্সাম যদি এরকম প্রশ্ন আসে, তো তুমি যদি শুধু বলে দাও যে এই ফার্স্ট লাইনটা লিখলে, সাপোজ আফটার রাইটিং দিস লাইন ইউ জাস্ট রিটেন ইট ইজ নোন দ্যাট দিস সিরিজ ডাইভার্জেস, সাপোজ ফর এক্সাম্পল, and hence we can say the system is not Bibot stable. It is answer. You will get suppose if it is right, you will get only 1 mark out of 5, because we know it diverges. This statement is not applicable here. How do we know? We have to show that. We have to show, or at least give some hints here in this context, that these are the reasons due to which I am actually arriving at this conclusion. We know এরকম ধরনের কোনো ভেগ স্টেটমেন্ট কিন্তু চলবে না, এটা মনে রাখো, আমি এই কনটেক্সটে বললাম, বাট ইট ইজ ইন জেনারেল ট্রু, ঠিক আছে? যখন তোমাকে মানে এটা মানে হচ্ছে তোমাকে এটা দেখা, মানে ইনডাইরেক্টলি বলা হচ্ছে যে তোমাকে এটা দেখাতে, কারণ আদারওয়াইজ এই প্রবলেমটা আর কিছু নেই। 5 নম্বর তোমাকে আমি এমনি দেবো না, বুঝতে পেরেছো? জাস্ট এই লাইনটা লিখে উই নো এটা বললে কিন্তু হবে না, আমি বলে দিচ্ছি ক্লিয়ারলি। যে তখন বলুন না স্যার আমি তো ঠিক করেছি, নম্বর পেলাম না কেন? নম্বরটা পেলে না ওই জন্য, জাস্ট আমি তোমাকে একদম ক্ল্যারিফাই করে দিলাম। হ্যাঁ এবার বলো।
স্যার n এর ভ্যালু গুলো যদি পুট করি, n equals to 1, তারপর n equals to 2 then 1 plus 1/2 plus 1/3 plus 1/4, এরপরে 1/3 plus 1/4 কে যদি অ্যাড করি আমরা, তাহলে সেটা স্যার গ্রেটার দেন 1/2 হচ্ছে।
ভেরি গুড।
তারপর স্যার ওরকম করে নেক্সট টার্ম তিনটাকে ওগুলোকে অ্যাড
বুঝে
করবো
গেছি
সেটা দেখা।
ওকে ওকে ওকে, ঠিক আছে, ভেরি গুড, একদম ঠিক, একদম ঠিক। তার মানে হাফ হচ্ছে হাফের থেকে বড়, ওটা যোগ করলে ওটা 1 এর থেকে বড় হয়ে গেলে আলটিমেটলি ইনফিনিটি থেকে বড় হয়ে যাবে, ঠিক আছে, মানে সরি মানে ইনফিনিটি হয়ে যাবে। সো ফাইন, গুড, ভেরি গুড, একদম। তো এইটা তুমি যদি করে দাও বা এই 3 লাইন লিখে বলে দাও, তুমি 5 পেয়ে যাবে, বা অন্য যে কোনো মেথড যদি তোমাদের জানা থাকে সেটা অ্যাপ্লাই করতে হবে। মোদ্দা কথা হচ্ছে এটাই। যাই হোক, ঠিক আছে, এটা বুঝলে তো? সুতরাং এটা হচ্ছে তোমার ডাইভার্জ করবে, এটা কিন্তু কনভার্জেন্ট নয়। সো ডাইভার্জ করবে, এবং যে লজিকটাও বললো খুব সুন্দর বলেছে। তো অ্যাকর্ডিংলি তোমরা বলতে পারো দিস সিস্টেম ইজ বেসিক্যালি বিবো, নট বিবো স্টেবল, দ্যাট মিনস বিবো আনস্টেবল। সেকেন্ড কোশ্চেন হচ্ছে, এটা ডিসক্রিট টাইম করলাম, এবার একটু কন্টিনিউয়াস টাইম করা যাক। কন্টিনিউয়াস টাইমে সাপোজ তোমাদের এরকম একটা সিস্টেম দিলাম, yt ইকুয়ালস টু ইন্টিগ্রেশন মাইনাস ইনফিনিটি। ভালো করে দেখবে প্রবলেমটা, খুব ছোট্ট প্রবলেম কিন্তু খুব ইন্টারেস্টিং। মাইনাস ইনফিনিটি টু টি x tau d tau. This is a system. This equation, differential equation, is representing a system, continuous time system. Now you just tell me whether this system is stable or Bibo stable or not.
স্যার এটা টাইম ডিপেন্ডেন্ট হয়ে যাচ্ছে না?
টাইম ডিপেন্ডেন্টের সঙ্গে স্টেবিলিটি কি সম্পর্ক?
স্যার এখান থেকে আমরা মানে h of t টা আইডেন্টিফাই করতে পারছি।
আচ্ছা, কি হবে h of t? ওকে, ভালো কথা, তোমার কথাই শুনলাম, h of t। ওকে, h of t কিভাবে আইডেন্টিফাই করতে পারছো, কি হবে?
u of minus t হবে কি?
u of minus t মানে কি h of t এক্সপ্রেশনটা বললে, ফর্মটা? u of minus t, u of minus t এখানে মাইনাস ইনফিনিটি টু টি হচ্ছে, u of minus t কেন বললে? এটা 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 আমি সম্ভবত তোমাদের প্রথম দুদিনের ক্লাসটা যদি তুমি বাদ দাও, মানে যখন তোমাদের বিএসসি বিটেকরা যখন জয়েন করেনি, হ্যাঁ, তখন আমি এটা করাইনি। তারপরে ওরা জয়েন করার পরে মানে সেকেন্ড ফেজের যে ক্লাসটা আমি আরম্ভ করেছিলাম, সেখানে কিন্তু আমি সম্ভবত প্রথম 1-2 দিনের মধ্যে এটা করিয়েছিলাম, মনে পড়ছে? ইম্পালস ফাংশন, স্টেপ ফাংশন, এগুলো প্রত্যেকটা জিনিস যে বিভিন্ন রকমের কম্পোজিট সিগন্যাল কনস্ট্রাক্ট করা, সেইখানে রীতিমতো এই ডেফিনেশনটা আমি করিয়েছিলাম, মাইনাস ইনফিনিটি টু টি। এটা তুমি এখানে কি করবে?
ইন টার্ম অফ সামেশন।
হ্যাঁ হ্যাঁ হ্যাঁ,
ইন টার্ম অফ সামেশন রিপ্রেজেন্ট করতে হবে প্রথমে এটা।
না, সামেশনে কেন যাচ্ছ তুমি? ইন্টিগ্রেশনেই দেখো না, সামেশন আমি তো কন্টিনিউয়াস টাইম ডোমেনে বলছি। সো ইন্টিগ্রেশনে তুমি যদি মাইনাস, সো ইওর x টাউ x উইল বি রিপ্লেসড বাই কি? ডেল্টা, তাই তো? সো তুমি যদি এখানে ডেল্টা টাউ ডি টাউ করো, তুমি যদি ইন্টিগ্রেট করো ফ্রম মাইনাস ইনফিনিটি টু টি, তুমি কি পাও? ভেরি গুড, বা ইউ নট টি, ভেরি গুড। এই তো আমি তো নিজেই করিয়েছি তোমাদের ক্লাস, ইউ নট টি বা ইউ টি হোয়াট এভার, ঠিক আছে, ইউ নট টি। সো এটা পেলে, সো তোমার এইচ টির ভ্যালু কত হলো? এইচ টি তো তুমি এখান থেকে পেয়ে গেলে, কিন্তু তোমার এবার আমরা কি দেখবো? আমরা দেখবো যে এটা অ্যাবসলিউটলি ইন্টিগ্রেবল কিনা। যদি অ্যাবসলিউটলি মানে ইন্টিগ্রেট করলে, ইন্টিগ্রেশন যদি করি মাইনাস ইনফিনিটি টু প্লাস ইনফিনিটি, মানে অ্যাকচুয়ালি এটাকে বা এটাকে একই ব্যাপার, এখন যদি এটা ইকুয়ালস টু এটা, সো করলে ডিটি করলে যদি সেটা ইনফিনিটি থেকে ছোট হয়, মানে কোনো ফাইনাইট ভ্যালু পাই, তাহলে আমি বলতে পারি যে এটা তোমার বিবো স্টেবল। আর যদি না হয় তাহলে নয়। এটা করলে কি পাও? ইউনিট স্টেপটা যদি তুমি ইন্টিগ্রেট করো, তুমি কি পাও?
ডাইভারজেন্ট।
এক্স্যাক্টলি, ডাইভার্জ করে যায়, ঠিক বলেছো, এক্স্যাক্টলি। তার মানে নট অ্যাবসলিউটলি ইন্টিগ্রেবল, তাই তো? ভেরি গুড, নট অ্যাবসলিউটলি ইন্টিগ্রেবল। তো তার মানে কি হচ্ছে? সিস্টেম তাহলে কি হবে? আনস্টেবল হবে, নট বিবো স্টেবল। তো বেসিক্যালি এই সিস্টেমটা কি সিস্টেম দেখো তো? এটা অ্যাকচুয়ালি ইন জেনারেল এটা একটা ইন্টিগ্রেটেড কন্টিনিউয়াস টাইম ইন্টিগ্রেটেড সিস্টেম, which is basically unstable system. ওকে, যাই হোক, এরকম ছোট ছোট দু একটা এক্সাম্পল আমি জাস্ট দিলাম, মানে মানে আইডিয়াটা দেওয়ার জন্য যে কিরকম ধরনের আসে। কিচ্ছু নেই এর মধ্যে, কঠিন কিচ্ছু নেই, জাস্ট একটু চোখ কান খোলা রাখবে, তাহলেই দেখবে ব্যাপারটা পারছো। আর কোনো টাফ ব্যাপার কিছু নেই এর মধ্যে। আচ্ছা, আর একটা জিনিস আমি একটু করাবো, করে আজকে মতো কমপ্লিট করব। আচ্ছা, আরেকটু কন্টিনিউ করলে তোমাদের অসুবিধা আছে? আর যদি 6:30 অবধি পড়াই?
স্যার আমাকে স্যার বাইরে
আজকে ক্লাস আছে? আচ্ছা ঠিক আছে, তাহলে আমি হ্যাঁ, কি আরেকজন কিছু বলতে যাচ্ছিলে? কি বাইরে কি বলতে যাচ্ছিলে?
না স্যার, আমাকে বাইরে ক্লাস করতে হয়, বাইরে ক্লাস করতে হয়, আমার নেটওয়ার্ক থাকে না স্যার। সেই
তোমাকে বাইরে ক্লাস করতে হয়? তুমি কোথায় থাকো?
হ্যাঁ স্যার, আমাকে বাইরে ক্লাস করতে হয়, নেটওয়ার্ক থাকে না স্যার।
না, তোমার বাড়ি কোথায়? মানে তুমি কোথা থেকে ক্লাস করছো এখন?
আমি স্যার এই
আমি শুনতে পাচ্ছি না তোমার কথা।
হ্যালো হ্যালো স্যার।
হ্যাঁ বলো, আমি মাঝখানে কথাটা কেটে গেল, আবার বলো।
আমার নেটওয়ার্ক থাকে না এখানে স্যার।
আমি সেটাই তো জিজ্ঞেস
প্রবলেম।
করছি, তুমি কোথায় থাকো?
আমি স্যার সিংড়াবলের পাশে একটা গ্রামে থাকি,
ও
বাঁকুড়া।
আচ্ছা 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 আচ্ছা। তা তোমাকে ল্যাব করার জন্য আসতে হয় না এখানে?
হ্যাঁ স্যার যাই ল্যাব করার জন্য, আগের দিন বুধবার দিন আমি যাই,
আবার বাড়ি
বুধবার
চলে
দিন
যাও? আবার বাড়ি চলে
রাত্রেবেলায়
যাও?
বাসে যাই। হ্যাঁ
আচ্ছা
স্যার।
আচ্ছা
হ্যাঁ
আচ্ছা আচ্ছা। ও ঠিক আছে, আচ্ছা ঠিক আছে, আমি আর কন্টিনিউ করছি না, আজকে আমি স্টপ করছি। আচ্ছা, তোমরা কে কে আছো আমাকে একটু পরপর বলো তো। অল্পজন আছো, কে কে আছো আমাকে না রোল অনুসারে বলো। প্রথমে 3
স্যার
ইয়ার্স, প্রথমে
উদয়
3
সন্নিক
ইয়ার্স, দাঁড়াও জাস্ট মিনিট, আগে 3 ইয়ার্সটা বলো। 3 ইয়ার্সে পরপর বলো কে কে আছো।
স্যার উদয় সন্নিক রোহিত 319।
319।
হুম
স্যার 308।
আচ্ছা দাঁড়াও, 319 আগে আমি দিয়ে দিই যখন বললো। 308 বললে?
ইয়েস স্যার।
308। তোমার নাম কি?
স্যার ইন্দ্রিলা চ্যাটার্জি।
আচ্ছা, আর কেউ আছো 3 ইয়ার্সে?
309
325।
দুজন একসঙ্গে হলো, একজন করে বলো। 309।
ইয়েস স্যার।
ওকে, আর একজন হচ্ছে কি 30 কত বললে?
325।
325। ওকে,
Yes, sir.
325। ওকে ঠিক আছে, আর কেউ 3 ইয়ার্সে? আর কেউ নেই। এবার 4 ইয়ার্সে, 4 ইয়ার্সে বলো। 438।
431।
আচ্ছা 438 হলো, 431 হলো। আচ্ছা আর কেউ?
430।
430 হলো।
428।
428। আচ্ছা 428, বেশ 428 হলো। আর কেউ? 4 জন হলো, আর কেউ আছো?
406।
406। 406। ওকে 406, 406 তাহলে 5 জন হলো। আর
So 408.
408।
Yeah.
ওকে 6 জন। আর কেউ 4 ইয়ার্স? আর কেউ নেই, তাই তো? ঠিক আছে ঠিক আছে, তাহলে আমরা আমাদের নেক্সট ক্লাসটা তাহলে থাকে কবে যেন? বুধবার, তাই তো? নাকি না মঙ্গলবার?
বুধবার।
স্যার ওয়েডনেসডে।
ওয়েডনেসডে ফ্রম 2:30। ওকে
ইয়েস স্যার।
ঠিক আছে।